Right, with this video we get to the hard parts of electrolysis. If you haven't got a good grasp of electrolysis already, kind of strongly suggest you have a look at the 3 videos that we've already done on electrolysis. That's introducing electrolysis, electrolysis of molten lead bromide, and electrolysis of water. Because what we're going to look at in this video is the electrolysis of solutions. If we take as an example here the electrolysis of sodium chloride aqueous. Now, let's just go back a stage before we get onto that for a moment. If we were to do electrolysis of sodium chloride NaCl liquid, that would be much more straightforward. Because electrolysis is a decomposition reaction. In other words, it's going to break that compound apart using electricity. So the products of that would be very simple. It would just be sodium and chlorine, Cl2. Because the only ions present would be the sodium ion and the chloride ions. The sodium ion would go to the negative electrode, the cathode. The chloride ion would go to the positive electrode, the anode. Having said that, this is more difficult because this is the electrolysis of sodium chloride aqueous, NaCl aqueous. And that means we don't just have 2 ions present. If you remember the electrolysis of water, we also have hydrogen ions and hydroxide ions present. So water, when it's electrolyzed, breaks down into oxygen and hydrogen, because water itself is made up of hydroxide, OH minus ions, and hydrogen ions, H plus ions. And that's why we get those. So in the electrolysis of sodium chloride aqueous, what we have present are sodium ions for the sodium, chloride ions from the chloride. Now the AQ means aqueous, aqua if you like, water. So we also have hydroxide ions and hydrogen ions. We have 4 ions present. And that's why the electrolysis of solutions is more complicated. And it's more complicated because only one substance can be produced at the anode and one substance can be produced at the cathode. If we look at this, the cathode is the negative electrode, okay, here, down this diagram, and the anode is the positive electrode over the other side. So let's just label those before we go any further at all. So in here we've got sodium ions, chloride ions, hydrogen ions, and hydroxide ions. Okay, so when we turn the current on, you'd expect the hydrogen ions to be attracted to the cathode and the sodium ions to be attracted to the cathode. Now the problem is only one can be produced, and we have to learn the rules about which one it is. So to learn which one it is, for the cathode, for these cations, okay, we need to look at the reactivity series. And it's very simple. When we know the rule, if we don't know the rule, it's not simple. Here's our hydrogen ions here, okay, and what we have to look at is what other cation is present. Okay, now we've got sodium chloride, so the sodium, the Na plus, is the other cation that's present. And the rule is very simple. The least reactive one is given off. Okay, so if anything more reactive than hydrogen is present, then hydrogen is produced because the hydrogen ion wins. Okay, if anything less reactive than hydrogen is present, the metal is produced. And it's often produced by being plated onto the electrode. Okay, so here, down here now, we've got hydrogen and sodium going to that cathode. The least reactive one is the hydrogen, because sodium's really high up the reactivity series here. So sodium is not given off. So the hydrogen goes over there. And what we end up with is lots of hydrogen ions going over here. And we end up seeing bubbles of hydrogen being produced. And in this apparatus here, because lots of these apparatuses can look different. In this one, we've got the electrodes coming in the bottom. Okay, and we've got little test tubes over the top of the electrode. So all these bubbles of hydrogen gas are going to float to the top here, and we're going to end up with bubbles of hydrogen gas produced there. Okay, right, now that's the rule for the cations. The rule for the anions, unfortunately, is different. And this is why most students can't do this, because they don't get as far as understanding about electrolysis, and then if they do, they don't learn these rules. Okay, so this time for the anions going to the anode, the negative ions going to the anode, we've got chloride ions and hydroxide ions. Okay, now the rule here is in this table here. There's a couple of ways to remember this. Chloride, bromide and iodide, they are all in the halogen group. So if we get a periodic table, this was a halogen group here: fluorine, chlorine, bromine, iodine, astatine. If you ever start with a halogen, a halide, then the halogen is produced, that gas is produced. That's how I often tell classes to remember it. Another way of remembering it is to look at these ions here, look at these cations. Look at these anions, get my language correct, look at these anions over here. The simple ones, the chloride, the bromide and iodide, they produce the elements. If it's a more complex one, okay, then they lose out, like sulfate, for example, sulfate or nitrate. They're not produced. In those cases, we get oxygen. A bit more about that in a moment. So if we start with a chloride, a bromide, or an iodide, then the halogen is produced. Well, down here, okay, we're starting with Cl-, the chloride ions. So we've got chloride and hydroxide ions. In that case, the chloride, that is the one that is produced, because if you start with a halogen, a chloride, a bromide, or an iodide, or an ion that's just made of one ion, as opposed to a more complex ion like sulfate, then the chloride is produced. So here, same ways, we get lots of bubbles of chlorine giving off, like so. All right, so we can label that up there, Cl2 gas. Right. If we did start with something like a sulfate, and we will in other examples later on, then oxygen is produced. You may say, why is oxygen produced? The oxygen is produced because in that case, if we start with a sulfate or a nitrate, it's the hydroxide ion that would win. The hydroxide ion win. When the hydroxide ion touches the anode, oxygen and water is made. I wrote oxygen down here in the book because you'd see the oxygen bubbling off, but you don't see the water, but it's made as well because the hydroxide has hydrogen in it. So the oxygen makes the O2, but also we end up with some water. If you like, that is the same equation for the electrolysis of water when the hydroxide makes oxygen and water. Okay, so let's just label the rest of this up and do some equations for these electrodes. So what travels towards the anode? Well, the chloride and the hydroxide travel towards the anode, but it's the chloride that wins, so I'm going to write the chloride travels towards the anode, and we can write there and turns into chlorine. What travels towards the cathode? Well, the sodium and the hydrogen ions will be attracted there, but the hydrogen is less reactive. If we remember this table up here, the hydrogen is less reactive. So the hydrogen is the one that's produced. So I'm going to write down here the hydrogen ion, and it turns into hydrogen. And that's going to be quite useful for the next page because we're going to do some half equations now. So for the half equations, if you like, just simply tell the story of what happens in this. Let's leave that there and see if we can do these half equations. Why is hydrogen produced and not sodium? Well, if you remember, the hydrogen ion, the H plus ion, is going to that cathode. The Na plus ion is going to that cathode, the negative electrode. The hydrogen is produced because the hydrogen ion is less reactive. Hydrogen is less reactive, and that's how we're going to remember that. What is the solution that's produced as a result of the electrolysis? Now, that's a really great question. Let's come back to this diagram for a moment. We've said the hydrogen hits that electrode and turns into hydrogen gas. The chloride hits that electrode and turns into chlorine gas. Well, that leaves in solution these two ions left behind, doesn't it? Look at that. Those two there are left behind. The Na plus and the OH minus. The Na plus, sodium, OH minus, hydroxide. So what's left behind is sodium hydroxide. So down here, what's left behind? Sodium hydroxide, NaOH. And that's also a very valuable chemical, so that can be sold off when this is done in industry. Sodium hydroxide. Right, now the equations. Okay, write equations, what happens to the cathode and the anode. Anode, positive electrode, cathode, negative electrode. Well, let's look at what we've done here. What travels towards the anode, the chloride ions, the chloride ion travels towards the anode and turns into chlorine. And turns into is the arrow and turns into chlorine, Cl2. First thing we've got to do, balance this equation. One chloride ion, two chlorine atoms in the molecule. We need two chloride ions to do that. Okay, this has got a negative charge, this one. Electrons are negatively charged, so this chloride ion has got to lose that negative charge to turn into the chlorine molecule. Okay, so it loses the negative charge. We can't write minus electrons because this is a chemical equation. If it loses electrons, the electrons are products, E minus. One chloride ion will lose one electron, two chloride ions will lose two electrons. Cathode, negative electrode. What travels towards the cathode? The hydrogen ion. The hydrogen ion touches the electrode and turns into hydrogen, H2. Exactly the same way, one hydrogen ion, two hydrogen atoms in the molecule, so we need two hydrogen ions there to balance that out. This time, this has got a positive charge. It needs to lose that positive charge to become the neutral molecule. To lose that positive charge, it's got to add negative charge to it. So we need to gain electrons. One hydrogen ion will gain one electron, two hydrogen ions will gain two electrons. Oxidation and reduction, remember, oil rig, oxidation is loss of electrons, reduction is gain of electrons. I always think reduction is easier to spot. The hydrogen ion gains electrons, so the hydrogen ion is reduced, the H plus ion. It's the hydrogen ion that's gaining electrons, not hydrogen. The hydrogen ion, so let's write that in brackets there to really make that point. The hydrogen ion. Right, oxidation. Oxidation is loss of electrons. Well, the chloride ion was losing electrons. There are their products. Therefore, the chloride ion, the Cl minus ion, the chloride ion, that is oxidized. And that is the electrolysis of sodium chloride in solution, sodium chloride aqueous. Now, there's plenty other examples in the specification, and I'll put those into another video, and we'll try and get all those done in another one. Okay.